Good morning children. Welcome to our chemistry online class. So last class we discussed about the physical properties and its trends in the periodic table. So in today's class we are going to deal about the trends in periodic table regarding chemical properties. So let's start. So the chemical properties are oxidation and valency and its reactivity. So let's see one by one. So what do we mean by oxidation state or valency? We know that the valency is the combining capacity of an atom, or it is the number of electrons in the valence shell, or we can define valency as the number of electrons needs to attain stability, or we can define it as the number of electrons which can donate or accept in order to attain stability. And we'll check what are the variation or trends in the valency in a group. For that, we'll take two groups elements that are this group 1 elements that are alkali metals. So if we check these elements in a group, moving down a group, the number of valence electrons are 1. For example, if we check lithium, its configuration is, what is the configuration of lithium? It is 2, 1. And if we check sodium, what is the valency? Its atomic number is 11, hence is where its configuration will be 2, 8, 1. So it is 2, 8, 1. And if we move down, if we check the valency, all having the same number of valence electrons. So we know the valency is the number of electrons in the valence shell, hence the valency also 1. And if we check the elements in the group 15, and if we check its configuration, it is also same. If we check nitrogen, its atomic number is 7. The electronic configuration will be 2, 5. Is 2, 5. So its number of electrons in the valence shell is 5. And what will be the valency? Either in order to attain stability, it needs 8 electrons. Either it can donate 5 electrons and attain stability, or else it can accept 3 electrons and attain the stability 8. So the valency, it will show two valencies. Those are 3 and 5. From group 13 to 17 will show two valencies. So we can call, they will show two valencies. But if we move down the group, we can see that all elements having the same number of valence electron, hence the all elements having the same valency down the group. So what is the trends in the valency? For every elements in a group having same valency. They all having valency. Okay. Then what will be the variation in the period? If you check the period, if you move from left to right, what will happen? If you move from left to right, this second period element, we can see valency is increasing. The number of valence electrons increases, hence the valency increases moving left to right. And if we check the noble gases, those are neon, helium, argon, krypton, they have 8 electrons in the valence shell. So they already completed its octet. Hence, those are highly stable. So they are showing zero valency. We can call it as zero valency because they need not to accept electron or donate electron. They are highly stable. So the variation of valence in period is moving left to right, the valency or oxidation state increases. And if we check the periodic table, the second group elements, they will show some anomalous behavior. If you take a classroom we compare the periodic table as a classroom. In a classroom, some students will show some anomalous properties. Anomalous behavior means different properties or different nature. Similarly, if we take a periodic table, some elements will show some anomalous behavior. The second period elements always show some anomalous behavior. For example, if we check lithium, lithium always form simple oxide and nitride. Whereas the second group elements, lithium will come under the first group, whereas the first group elements other than lithium will not form simple oxide. And if you take beryllium, it will show the covalent bonding, whereas the other elements, they will not show the covalent bonding. And if you check boron, it will form boranes. It is a complex compound, whereas other elements in the group except boron will not form this complex form. So why these elements are showing this behavior? Because due to these several reasons, that is, those having small size compared to other elements. For example, if you take the first group elements, lithium having small size compared to other elements. They have very small atomic number and they have it has very small size and small atomic radius, and it is very small compared to other elements. Compared to sodium, potassium, rubidium, cesium, lithium is very small. It is one of the reason. And the second reason is the charge by radius ratio. If we take the elements, their charge by radius ratio will be very small because they have less atomic radius. So the charge by radius ratio also very less. Hence, it is show different properties. And high electronegativity. Compared to the other first group elements, lithium having high electronegativity. We know down the group electronegativity will decreases. So lithium having high electronegativity compared to other first group elements. And they have the ability to form pi-pi bonds between themselves or with other atoms. For example, if you take carbon, carbon having the ability to make pi-pi bond. Pi-pi bond means unsaturated bonds. And no other element having in the carbon family have the same property. And it has the ability to attack with nitrogen and oxygen. If we check other elements also in the second period, they have the ability to form pi-pi bonds. These are the reasons. And if we check the second period element and third period element, they will show some relations diagonally. If the diagonally placed element show some properties with the diagonally placed element in the period 2. For example, if you take lithium and magnesium, they are both hard. But if we compare sodium with lithium, we know sodium is a soft metal, potassium also soft metal, but lithium resembles to magnesium. But we know all elements in a group have to show same property. But in the case of lithium, lithium resembles to magnesium than sodium or than any other metal. Then lithium and magnesium forms weak bases, whereas sodium will make strong bases. And both of this element will show covalent character, and the chloride of this element soluble in ethanol, and if they reacts in water, the reaction will be very slow. But if you check the other elements in the first group, sodium, potassium, they are highly reactive towards water. If we put some sodium or potassium in water, there will blastic reaction will occur. So hence the sodium kept in kerosene. This is the main reason why sodium kept in kerosene. It is highly reactive towards water. But in the case of lithium, it is very less reactive. The reaction rate will be very slow with water. Even magnesium. So why these elements are showing this property? If even check the beryllium and aluminium, boron and silicon, carbon and phosphorus, they will show similar properties. Why it is happening? Why it is not the same group element showing these properties? Why? Because this is known as diagonal relationship. What is diagonal relationship? On moving diagonally across the period, this element showing some resemblance in properties with diagonally placed element. Similarities. So even though the similarity is not same as we see in a group, it is showing in a pair of elements. This similarity in properties existing between the diagonally placed elements is called diagonal relationship. So can you name some pairs? Lithium magnesium, beryllium aluminum, boron and silicon, and carbon and phosphorus. So what will be the reason? Reason both having same size, same charge by radius ratio, almost similar electronegatividity. These are the reason for the diagonal relationship. And we move to the next topic, the chemical reactivity. In order to understand the chemical reactivity, there are two factors which affect chemical reactivity. One is ionization energy and the second one is the electronegativity. So what is the ionization energy? It is the amount of energy released when it is the amount of energy required to remove an electron from the isolated gaseous atom. So it is the amount of energy required to remove or take one electron from an shell of the atom. So if less ionization energy, which means we can easily remove one electron from the valence shell. So if we check in a group, we can see the variation and trends. And another factor is its electronegativity. Electronegativity is the ability of an atom to attract shared pair electron towards itself. So if electronegativity is high, we can say that the elements are very reactive. In order to get one electron, they will undergo reaction very easily. So we'll check the trends in group and periods. This properties determines the metallic character and non-metallic character. So let's see. So in the case of metals, we know in the periodic table, in the left side there are more metals. Moving left to right, the metallic character decreases. So if we check, in the case of metals, the chemical reactivity decreases as you go left to right of the periodic table. As moving left to right, the metallic, in the case of metals, the chemical reactivity decreases. Why? Because moving left to right, we know that ionization energy increases. Because why it is increasing? The size of the atom will be decreases and effective nuclear charge will be increased. So in order to take or remove one electron from the valence shell, we need to give more energy. So ionization energy will be very high in the case of, if we move left to right, the ionization energy will be very high, increases. So the chemical reactivity decreases. Then ionization energy increases as we move down the group. Hence the chemical reactivity also, ionization energy decreases down the group. We know if we move down the group, what will happen? The size of the atom will increases. And in order to remove one electron from the valence shell is very easy. So it will undergo reactions very easily. But in the case of non-metals, the chemical reactivity increases left to right because they are highly electronegative, for example fluorine. And if we check the chemical reactivity of non-metals decreases as you go down the group. in the basis of electronegativity. So these are the chemical reactivity of the element. So I hope all of you understood. Thank you.
Good morning children. Welcome to our chemistry online class. So last class we discussed about the physical properties and its trends in the periodic table. So in today's class we are going to deal about the trends in periodic table regarding chemical properties. So let's start.